every class is today. Let's get in. Let's get as much information that you guys need for right now. Then let's get done and have a weekend apart and away from all this. You guys get Monday and Tuesday mostly apart as well. Wait, Monday and Tuesday? How is that weird with the backboard? I heard some of you guys guessing what was going to happen. What's weird about the backboard? It's due on Tuesday, but wait a minute. Wait a minute. What am I trying to do today? Finish 8-4 entirely. So when should homework be due? Monday. When am I having it due? Tuesday. I'm giving you a couple days in the weekend to get it done. And then what are we doing on Wednesday? 8-5. Might I have it due at 8 a.m. on Wednesday morning? Sure. I don't care. Whatever. Tuesday night, Wednesday morning. I'm probably not going to be teaching anything on Monday or Tuesday. We're trying to pack it in today so that way it's hey, we're still on schedule. Sure. I can make it due 8 a.m. Wednesday morning. But either way, you guys know I'm giving you grace time. Cool? Ready? Set? We're already recording. You guys have your 8-3 open? Let's go ahead and check the evens. I'll write down any questions that anyone has, and then we'll go cover 8-4, get that done, so that you don't have to go find a video Monday or Tuesday. You can technically finish this homework this weekend and just have a break from math Monday and Tuesday if you want it, or you could be busting out homework Tuesday night and have a 4-day weekend. But either way, I think I might be able to finish early and answer homework questions. If not, I'll have a record of which questions you guys have, and I'll just include that on my video Wednesday morning as far as, or the one I'm posting Wednesday morning as far as homework questions, homework help, and then moving on. Okay, so section 8.3. Number 10 was pretty easy in the sense of you were just supposed to get the identity matrix. Either way, you multiplied it because, yes, it was an inverse. Number 18 was having you practice row reducing. Number 18 was having you practice row reducing. And row reducing when you doubly augment a matrix with the identity in order to undo the one and build the other, build the inverse. It was possible, and it becomes 1, 1, 3, 4. Okay. Number 20 is a much bigger one. However, A, B, C, D, E, F, G, H, I would have been a nasty way of solving for this inverse. It's much easier to doubly augment. Just do your row operations if you've gotten them down by now, if you've been doing them since section 8.1. You end with your inverse, and your inverse is, but guys, what's awesome in all of these evens, you just plugged in the matrix to check and make sure your answer was right, because there's that cool x to the -1 button. Number 40, you were just doing a determinant, but it was with fractions. Were you able to do it? I know it's silly, but by pre-cal, and by the end of pre-cal, I really hope that you're not afraid of fractions anymore. It doesn't mean you love them. Just hope you're not afraid of them. Anyway, the determinant ends up being -143 over 36. When you plug into the formula for the inverse, you just do 1 over, which is the reciprocal. Switch the main, opposite the opposite, and then if you wanted to, I think I would have been lazy and been you know what I mean, but you can multiply too. 50 was a little bit nicer. You just had to use your math skills a little bit more since the numbers got bigger. But at the end of the day, you find the inverse. You're multiplying it by those constants, and you end up with your x equals y equals. I know you can use substitution. I know you can use elimination. I know we've learned 5 different ways to do this problem. It's just showing you the idea of how to truly solve with matrices a good old-fashioned, but with harder functions, algebra equation. How do I get to x? Inverse both sides, aka multiply both sides by a inverse. It's learning how this algebra idea applies to matrices. I know you could have solved it. And I think that's it. So let me write on the board. Is there anything that you guys would like me to look at after I cover 8-4 if we have time? Number what? Oh, you were just talking. Nothing? Yeah. 77. Did you guys have another word on last night? Oh, 8.1. Thanks. I was wait a minute. I thought 71 was the last one. Cool. Thanks, Cody. Anything else? Yeah. Yeah. Guys, I'm going back to 8.1. I'm going back to 8.2 to make you keep reviewing, because some of these things, once you get to a new section, you totally forget the last few, especially in this chapter. So let me go ahead and get the PDF up on that. But as I get the PDF up, let me get you guys going ahead and Oops, we haven't done that yet. Writing down the page we didn't get yesterday. I showed you, and for some of you, to be honest, to some extent, this might be enough. But for others of you, it might be helpful to actually talk about what the heck we just did as far as what is going on with this. So I'm going to go ahead and, ooh, can I make this bigger? I would love for you guys to be able to take down this. So let me actually switch the order of these pages. That way you guys can have me zoom in on this when it's appropriate. Let's go ahead and build our vocabulary a little bit. After the examples that we did yesterday, finding the determinant of a 3 by 3 using this weird circling, crossing out, what's left formula, let me have you get some vocab down first. As I get some pictures of the questions that you have. Let me have you get some vocab down first. Let me talk about this formula, which is technically this whole expansion by cofactors process of getting a determinant of any size matrix. Remember, math is only as helpful as it can be generalized, as it can be used generally. Once again, I'm throwing that out there. It's not like a hard, fast truth. It's just like math is more applicable when it can be generalized. Maybe I should be saying that. So this is the general process that can work for a matrix of any size, any order, which is exactly what a programmer would want. They don't want the special trick that makes it easier for the human mind. They are like, I have a machine. I just need something that will work every time. Freeze the screen and look for 77 and 33. You guys are writing down all kinds of new vocab right now, which, to be completely honest, isn't super crucial for the understanding. But if I give you a formula, you have to know what the pieces are, otherwise you're going to have no clue how to solve. If some geometry teacher gave you a square root of a squared plus b squared is c squared and never actually taught you a right triangle, who a, b, and c is, like, it could be the hardest formula in the world. Like, what are you talking about? You have to know what the pieces are and what they mean. So, as we come over here and as I zoom in on this formula in just a second, the hard part is there are actually a lot of different ways of writing this formula because of what you will see when we zoom in on the wording. You don't actually see it over here yet. What you see in the wording when I zoom in will be the following. It will say the sum of the entries in any row or column. Any row or column. You have an option, you have a choice, unless the book tells you do this row, like we talked yesterday. If they take away your freedom of choice, it's because they're trying to prove something to you, show something to you. And that's what I did yesterday with the example when we solved it 2 different ways, and I had you guys try to pick your own way to solve. This is, right now, this formula is based on choosing the first row. But before we get there, okay, 2 main terms, minor and cofactor. Minor is this little guy, when I was crossing out stuff yesterday, the guy that popped out, that's the minor. What's left when I ignore someone's row and someone's column? What's left is called the minor. Minor, you can think like sub, you can think below, you can think underneath. Minor versus major, there's a lot of different ways of kind of remembering that word. But it's the minor. And that one, the notation is just, do I have it there? It's just going to be M, M, N. And that little MN says which row, which column are you ignoring. So in this one, it's M11 because I'm ignoring the first row, ignoring the first column. Boom, there he is. In homework, it'll just ask you for a few of those M's. So you're just using or building that vocabulary like, oh, okay, minor is that little guy that pops out. Cofactor says, okay, I take that minor and I assign to it those little signs I was showing you yesterday, how it's flipping back and forth, but it depends where you are. Let me zoom in real fast just so you guys can see maybe a little more clearly than yesterday. There we go. What I meant by the signs alternate. Depending on where you are to get the cofactor, to get C sub M, N, which is the corresponding plus or minus, depending on where you are of the minor. Oops, sorry. I was using the example from up above. I could use the general MN. Cofactor says, give me this dude, and I'm going to put in front multiplying by a positive or multiplying by a negative. Real quick, the positive just means keep the sign the same of whatever that entry is that you're multiplying in front. Whereas negative says flip it or make it the opposite of whatever its natural sign is. If that entry is a negative and its opposite, a negative times a negative is a positive. So be careful of that. I'm not saying what the ending sign will be. I'm saying whether I'm adding or subtracting what's about to come or what's following. But if you guys notice, what's always the same regardless of the size of the matrix, where do I always start with alternating? Positive. Always start positive and then alternate down, across, over, etc. So I alternate positive, negative, that's a positive, that's a negative, that's a negative, that's a positive. And you can kind of figure out, depending on yesterday, didn't you choose your own row or column to expand that? Maybe your signs were off, like mine. I chose the second column or the second row. I needed to start negative, positive, and you guys saw that because you were like, the signs changed. And I said, yeah, they did, and this is why. So, minor, little dude pops out. Cofactor, give it the right sign, and here's your formula. Your formula says, to get any determinant of any square matrix of any size. Remember, determinant, like a dot product, super applicable in matrices, super helpful and useful, and used in math that uses matrices or arranges information in those rectangular arrays. The determinant is the sum of, ready? Here's your choice. Here's your freedom of choose what's better for you, although maybe you should practice it a bit before you decide what you think is always best, because maybe you're not exactly right. Or there's a better way. Any row, any column, the sum of the entries in any row, any column, those entries are being multiplied by, those entries are the A11, A12. Remember, this is using the first row, but it didn't have to. It could have used the second, it could have used the third, it could have used the first column, second column, third column. Take the entry and multiply it by the cofactor. The cofactor, that little minor that pops out, and the correct positive or negative in front. This is what's called expanding microfactors. Well, baby 2 by 2s. There's a great formula. 1 over determinant times. Switch the main opposite the opposite. But anything bigger, this is the way to go. And quick heads up on the informal assessment or the formal assessment once you get back. I might even give you a 5 by 5 or 6 by 6 and say solve. But if I do, you better hope there are tons of zeros, because the more zeros, the better. The more zeros, the better. So, checking this out. Just to help you with the vocab first of all, and then using it one more time to make sure we're okay. The vocab first of all, minor says, what's happening if I ignore first row, first column, and it's the determinant of that. I could do M11, M12, M21, M22. Why don't I have any 3s? Why not 3-1 or 1-3? Because it's a 2 by 2. All I have is 1, 1, 1, 2, 2, 1, 2, 2. That's all I got. So what happens if I ignore who's in the, or the first row, first column, who's in that 1, 1 spot? Hey, what's the determinant of any single number? Can you make sure that you are crossing out the right set though? How about 1, 2? What's left? First row, second column. It is a 10, but what's left? The 3. See it? This is telling me the spot whose row and column I'm ignoring. What's left is what's underneath, like a subheading, sub-level. What's underneath the 3? Okay, let's try again. How about 2, 1? It is the 3, but we're ignoring his row and column, so what's left? The 10. And then 2, 2? Yeah, good. Cofactor says, okay, I take this minor dude, and I just put the correct positive or negative in front. So the 1, 1 spot, where does every matrix start? What's in that far upper left-hand corner? Plus. Oh, so he's going to stay the same. The same as -4, yeah. But then as I go over, if he's a plus, he's a minus. But it's a positive 3. I don't care, you're subtracting it. Then, if that's a minus, this is a, and that's a, wait a minute. No, alternate. Yeah. I have to alternate. That's a plus, that's a minus, and that's a minus, that's a plus, and that should alternate. So minus 10 plus. But that's just identifying the vocab. It's just identifying the program. As to, oh, okay, minors are the little sub-level dudes. Cofactors say, I'll give you the right sign for the determinant process. Somehow it's stuck in my brain. Sorry. Full page. Okay. That's vocab. This is process. Now, the book is going to say do it more than one way, aka use row 2 and column 3. I showed you one yesterday where we already did it 2 ways. So you guys, based on maybe a lack of total experience besides yesterday, or maybe based on doing homework last night, or maybe just based on, I don't know, I have to use the numbers in them, which one do you want to do? Row 2 or column 3? Row 2 means 6, 3, 1. We're using those guys. Column 3 means 2, 1, negative 8. We're using those guys. Just pick one. Sure. And if this is one of those problems past the first few where it says use whatever you want, well, you just get to choose whatever you want. I heard column 3, so we're using it. We're using what? Well, we're using 2. We're using 1. And we're using negative 8. But we're multiplying each of those entries by the minor that's formed by crossing out their row and column. And right away, how do I know that's plus, that's minus, and that's plus as far as what sign to put in front? Where do I always start? And then I alternate. Positive must go then to, and then positive, negative, positive. Ha, ha, ha. But what are my minors? Think of the 2. If I cross out 2's row and column, what's that sub-level? If I cross out 1's row and column, what's left? Did I cross out? Oh, for the second one, yeah. For the third one. And just in case you guys somewhere got lost, remember, for whatever number is in front, whatever entry I'm using as I'm going all the way through said row or column, I'm ignoring his row, ignoring his column, and saying what's left. What do those little bars, sometimes absolute value bars, mean or when they're around matrices? How do I finish this one? I know with numbers, but not with matrices. Yeah, it's the whole section. It's just determinant. Wait, how do I do determinants of 2x2s?
Switch.
Yeah. Wait, no. Determinants. You're thinking inverse. Make it easier. Determinants just main, multiply the main, minus opposite. So I can say positive 2 times negative 42 minus 12. Main minus opposite. Minus, okay, your turn. Do you remember determinants? Main. Times, which is, okay, come on guys, we can do mental. 21, just multiply, but thank you, sweetie. 21, right? Main, 21 minus, okay, minus 8. I know, all of our brains are like a million places. Negative 9 minus 24. Whew. If some of you guys know how to use your calculators as we're finishing off this problem, you might be checking whether or not we've made a mistake. AKA, can you plug in A and find the DET and make sure it matches? Negative 9, negative 24, that's positive 33. We end up with negative 108 minus 5 minus, I think I had negative 9 minus 24, right? Which would be negative 33. Oh, gracias. So then I have plus, and I think it's 243? No, 240. 264. You guys okay? Laura, Nathaniel, we're good? Melissa, Kayla, we're good? Cool. So DET is what we're trying to do with matrix and math. We have negative 113. We do negative 113. We end up with 150. Okay, guys, there might be other homework help. So basically, you've seen Whoop, whoop. Can you double check your matrix real fast and make sure you put it in right? Can you double check your matrix really quickly and make sure you put it in right? Does anybody else also get the 183? Oh, math is good. Thanks. Okay, so there are some other homework helps. As I said, I could have kept going to doing a few other, ooh, it's bigger. Oh, but he has 2 zeros. And ooh, there are variables, but maybe it's not too bad. Hey guys, I really get annoyed if people are talking over me, which is why I ask you to learn to whisper. And I am teaching right now, okay? So then, as we are getting ready to finish off class, I did have up for you guys some of those ones that you were asking about, number 33 and number 77. I'm probably not going to have time to go completely through them. However, remember Gauss-Jordan, that's just simple row operation. So when you guys had a question on this one, all we were supposed to do was do those things that you were solving in 8.3 that theoretically you were able to get. Do you have questions on those? As far as like, hey, let's get a 1 in the first column by multiplying by the reciprocal. It's not going to be pretty, but definitely possible. And then let's get a 0 by multiplying by the opposite, whoever has that one. And we've done that process both in 8.3 when we were doing the doubly augmented and in 8.1. And you just wanted to get to 1001. And then this one, you were just doubling and then quadrupling and then setting equal to -2x. I'm still recording, so I'm going to finish so that you guys who have these questions can check this out online. The rest of you guys, I'll see you later. Love you, be safe. And I'll catch you online. And since it's a scalar, I'm not doing anything illegal with the matrix. Instead, all I'm doing is preserving all the matrix now, multiplying by a scalar. Scalars can just yeah, good question. And then this one, we finish. Oh, it's good. 5 times 5, 0. 5 times plus 4 times 9 times -35 8 plus 8 if you want it, if not, you do it those of you guys still watching the example, it's either multiply by the reciprocal in order to get my 1. That's going to be -3 over 4. Cool, I already know my 5. And solve for my x. All I have to do is that's sort of supposed to go all. So what if I do my positive 1/2 row 2 plus row 1, and then using this row 2 also? So 0, 1, got it. 1/2 minus 1/2, got it. And -27 16 plus 14 16 would be 30. Oh, no, I'm multiplying by the wrong one. Sorry guys, I'm doing 1/2 times -3/4. It would be -3 8 plus 7 8 is 4 8 plus 1. Got it. Bye guys.